Hi, and welcome to the code terminology presentation. In this module, we're going to define some terms for drain, waste, and vent systems and water supply systems, as well as some other miscellaneous terms that we're going to need to be familiar with throughout the plumbing code. Primary focus will be for piping systems that would be found in typical residential construction, with some attention to small commercial buildings. These first few terms are not necessarily defined in code, but are important to understand when using the code. For example, always remember that upstream is towards the source and downstream is away from the source. In this illustration, we show the effects of hydraulic jump as it occurs downstream of the base of a soil or waste stack. Upstream is the stack, downstream is the branch or building drain. Connections within this area are limited under the conditions that are set out in Article 2421, Sentence 2. The code specifies slope on piping in terms of ratio. The ratio stated is a comparison of a pipe's fall over its length, or rise versus run. For example, a pipe installed at 1 in 50 would fall 1 inch in every 50 inches, or 1 meter in every 50 meters, etc. This numbering system is used throughout the BC Building Code. The first 4 numbers indicate the part, section, subsection, and article in the subsection. The detailed provisions are located in the sentence level, indicated by numbers in brackets. All the parts of a drainage, waste, and venting system have definitions in Division A of Part 1. Once accurately named, you'll be able to source the appropriate code sections and tables required to size these systems correctly and determine minimum code requirements. Defined terms will occur in italics within the body of the code, and their meanings are explained in Section 1.4, Terms and Abbreviations. Additional explanatory material is contained in Division A, Appendix A, and Division B, Appendix A. It is important to understand the 3 categories of waste to determine the correct means of disposal. Stormwater, for example, results from rainwater discharge, snowmelt, or other natural sources. Storm systems are sized in liters of hydraulic load. Clearwater waste has low impurity levels and occurs from sources such as drinking fountains, condensate from cooling units, and discharge from relief valves on hot water storage tanks. Clearwater waste can discharge to either a storm system or a sanitary sewage system. Anything other than stormwater or clearwater waste is considered sewage. Sewage must discharge to a sanitary drainage system. Sanitary systems are sized hydraulically using drainage fixture units. Sanitary drainage systems convey sewage from fixtures such as water closets, bathtubs, and kitchen sinks. Sanitary systems connect to either a public sanitary sewer or a private sewage disposal system. Storm drainage systems convey liquid from roofs, parking lots, and other impervious surfaces. They often lead to a place of natural disposal, like a river or stream. Private sewage disposal in BC is governed by the Sewerage System Regulation, which was amended in June 2010. The regulation requires that only authorized persons, or homeowners under an authorized person's supervision, can construct or maintain Type 1 or Type 2 systems, which would include typical septic tanks and dispersal fields. Authorized persons include registered practitioners or professional engineers who are authorized to undertake on-site sewage installations. Subsoil drainage systems are commonly called footing drains or perimeter drains. They are intended to intercept and convey subsurface water away from the foundation of a building. The code doesn't regulate the installation of subsoil drainage piping, but it does regulate the connection of such piping to the plumbing system. See Article 2453 for more information. This diagram shows an example of how some jurisdictions may prefer the installation of subsoil drainage piping to be installed. Building sewers convey either sewage or stormwater to a public sewer, private sewage disposal system, or other approved location. The name building sewer starts when a building drain has exited a building for at least 1 meter. A building sewer is always downstream of a building drain. Building drains convey either sewage or stormwater to a building sewer. It includes the lowest horizontal sections that drain the main sections under a building. Building drains drain to building sewers. This illustration shows the relationship between the building drain and the building sewer. A sanitary building drain conducts sewage to a sanitary building sewer. Its most upstream location will be a branch, stack, or fixture drain that serves a water closet. There is only one path for a sanitary building drain in each sanitary system. Sanitary building drains are sized in accordance with Table 24.10.6c and will be a minimum of 3 inches in size. Sanitary building drains must be served by at least one vent in the system that is 3 inches in size, as per Article 2584, Sentence 5. Storm building drains conduct storm water from a leader to a storm building sewer. They are minimum 3 inch and sized in accordance with Table 24.10.9. A leader is installed to conduct storm water from a roof to a storm building drain or storm building sewer. They are located either inside or outside a building. They are minimum 2 inch and sized from Table 24.10.11 and in accordance with Article 24.10.4. Note that when leaders are installed inside buildings, protection from condensation may be required as per Article 2356. A combined building drain is a building drain that contains both sewage and storm water. In most areas, the installation of a combined building drain is prohibited as per Article 2121, Sentence 2. Although combined building drains are prohibited, some jurisdictions may permit the installation of combined building sewers. Combined systems convey both sewage and stormwater and can lead to widespread contamination when storm flows are heavy. Most areas attempt to maintain separate systems to avoid environmental pollution and unnecessary additional treatment of stormwater. When permitted, combined building sewers are sized in conjunction with Table 24.10.9 and in conjunction with Article 24.10.5. Branches drain 2 or more fixtures from the same story. A branch will drain to another branch, a soil or waste stack, a sump, or a building drain. Branches are sized from Table 24.10.6b and are to be installed at a minimum slope of 1 in 50, as per Article 24.8.1. This illustration shows a branch draining 3 typical bathroom fixtures: lavatory, water closet, and a tub or shower. This picture shows an underslab drainage rough-in. The water closet and bathtub are both wet vented symmetrically through the adjacent lavatory fixture drain. All 3 fixtures drain through a 3-inch branch as shown. Pipes that drain to a sanitary system are called soil or waste pipes. Soil pipes and waste pipes at one time had different meanings. Examples of soil or waste pipes include fixture drains and branches. Fixture drains and branches become soil or waste stacks when they pass through one complete story. Stacks drain to branches or sanitary building drains at their base, and the base of every stack requires a cleanout as per Article 24.7.1, Sentence 7. Soil or waste stacks are sized in accordance with Table 24.10.6a. Fixtures drain sewage or clear water waste to a sanitary drainage system. Fixtures connect to soil or waste pipes, and most are trapped to avoid the passage of sewer gases into occupied spaces. Examples of fixtures include water closets, lavatories, sinks, and floor drains. Drainage fixture units are arbitrary units used as a design factor for sizing of drain, waste, and venting systems. Although not an accurate flow rate, drainage fixture units represent the frequency of use and discharge quantity that a fixture may impose on the drainage system. Originally, drainage fixture units were calculated as the discharge of 1 cubic foot per minute draining through an 1.25" outlet. Although still based on this rate, fixture units include other factors used for design purposes. Drainage fixture units for fixtures are listed in Table 2493. The highest elevation that liquid can achieve in a vessel is considered its flood level rim. Vents for fixtures must rise above the flood level rim of every fixture served before connecting to other vents, as required by Article 2564, Sentence 1. Fixture drains are solar waste pipes that drain one fixture from one story to another part of the drainage system. A trap arm connects a fixture's trap to a vent and is part of the fixture drain. The total fall in a trap arm, based on 1/50 slope, must not exceed its size to avoid self-siphonage and trap seal loss. See Article 2563, Sentence 1. The total horizontal change in direction of a trap arm is also limited as per the requirements in Article 2563. This illustration shows the difference between a fixture drain and the trap arm portion of the fixture drain. Notice that the trap arm begins at the outlet of the trap and ends at the face of the vent pipe fitting. Trap arms and fixture drains are typically the same pipe size as the fixture's outlet. A fixture's outlet and outlet piping must conform to the minimum sizes that are mentioned in Table 2493. An outlet pipe connects the outlet of the fixture to the trap that serves that fixture. This sink waste tailpiece is an example of a fixture's outlet pipe. All the piping upstream of the trap is considered outlet piping. Continuous waste configurations under a 2-compartment sink is another example. Most fixtures are limited to a maximum allowable outlet pipe length of 1200 millimeters, as stated in Article 2482. Vent pipes and venting systems include the connected piping located above the drainage system. The purpose of a venting system is to maintain a neutral condition which protects fixture trap seals from positive and negative pressures. Ideally, a properly designed drainage and venting system will allow only a maximum plus or minus 1-inch water column differential in pressure. This chart shows the association between the different vents in a venting system and the priority when naming and sizing. Refer to this chart often as you work through sizing venting systems to properly understand the hierarchy of their relationship. Individual vents serve only one fixture and originate from a fixture drain. Individual vents are sized directly from Table 2571 based on the size of trap they serve. A continuous vent can serve 2 or more fixtures that connect to a branch or a fixture drain. They are a vertical continuation of a branch or fixture drain. Some types of continuous vents are either individual or dual types. Except for individual and dual types, continuous vents serve wet vented systems and are sized in accordance with Table 2583 and Article 2583, Sentence 5. This continuous vent serves a wet vented fixture drain. An individual vent that originates as a vertical continuation of a fixture drain can be called an individual and continuous vent, as it meets both definitions. Regardless, continuous vents that are individual or dual are sized from Table 2571 as per Article 2582, Sentence 1, and Article 2583, Sentence 1. This individual and continuous vent is roughed in to serve a separately vented lavatory basin. Dual vents serve only 2 fixtures and must originate from a single symmetrical fitting. This 3-inch vent is symmetrically connected to the junction of 2 trap arms. Dual vents that originate from a vertical branch can be defined as dual and continuous vents. This dual and continuous vent will serve 2 trap arms from the same double sanitary T-fitting. Note that when sizing any vent that is either individual or dual, the length is not a consideration. Refer to Article 2582, Sentence 2. A wet vent is a solar waste pipe that acts as a vent for 1 or more fixtures, so it's both a drain and a vent. Wet vents that serve water closets must be a minimum 2-inch in size, and all wet vents are sized correctly from Table 2581. This picture shows an underslab installation of a 2-inch fixture drain for a lavatory that is used as a wet vent for an adjacent flush tank water closet and bathtub. A circuit vent is installed when a battery of multiple fixtures are connected to a common branch. Circuit vents originate from the most upstream circuit vented fixture's trap arm and are sized in accordance with Table 2583 and Article 2583, Sentence 4. This installation shows a circuit vent that serves a bank of water closets on the story above. Relief vents are installed in conjunction with circuit vented systems. They originate downstream of the last circuit vented fixture's connection to the vented branch. Soiler waste pipes can sometimes act as the required relief vent and must meet the requirements of Article 2573. Here's a branch acting as a relief vent, which is installed downstream of 8 circuit vented water closets. Additional circuit vents are installed when more than 8 circuit vented fixtures are installed between vents. They are also required if the vented section exceeds more than 45 degrees between vents. Additional circuit vents must also meet the conditions of Article 2573. Branch vents are formed when 2 or more vents, other than stack vents, vent stacks, or vent headers, connect together. Branch vents are sized from Table 2583 in conjunction with Article 2583, Sentence 2. Stack vents connect to the top of every soiler waste stack. They are sized from Table 2584 and Article 2584. Their purpose is to facilitate flow in the vertical stack. A vent stack originates near the base of a soiler waste stack that receives drainage from fixtures located on more than 4 stories. Vent stacks must meet the requirements of Article 2542 and are sized from Table 2584. Their purpose is to limit positive pressures that can develop at the base of a stack. Vent headers connect 2 or more vent stacks or stack vents, or a combination of both, to outside air. They are sized in accordance with Table 2583 and Article 2583, Sentence 3. When a soiler waste stack has a nominally horizontal offset, more than 1.5 meters in length, there is a substantial reduction in the flow of waste within the stack. Offset relief vents are required when the stack has more than 2 stories draining more than 100 fixed units above the offset. One vent is required at the end of each section as per Article 2544 and are sized according to Article 2574.